What is acoustic comfort? Our ears developed in natural environments, where we are still the most audibly comfortable. Their main purpose has always been to warn us of approaching danger, and to allow verbal communication. But today's world is much more. Urbanization, together with greater numbers of noise-producing equipment and activity, have dramatically changed our sound environment. A comfortable acoustic environment can be defined by the quality of sounds we want to hear, and the absence of sounds we don't want to hear. Also, being able to make sounds without annoying other people is also part of acoustic comfort. With this definition in mind, it is clear that the modern environment brings new acoustic challenges to our day-to-day lives. Taking these challenges into account when designing a building is key for the comfort and well-being of its users. Besides the obvious hearing loss, exposure to noise can have other undesirable effects on health. It can be particularly harmful at night in disturbing our sleep. Scientific studies, however, show that in well-designed sound environments, students learn more effectively, patients recover faster, and stress can be reduced. Protection from noise exposure contributes to a sense of security and privacy. The physiological aspect of acoustic comfort. The human ear is comprised of three parts. 1. The outer ear receives sound. 2. The middle ear transmits vibration to. 3. The inner ear, which translates this vibration into information, which is then sent to the brain. Hearing is the only human sense that fully functions while we sleep. The physical aspect of acoustic comfort. Sound is a vibration, which is a pressure fluctuation that grows as it travels through the air or through water. The distinction between loud and quiet sounds is made by the difference in scale of the pressure changes, commonly measured in decibels. A quiet indoor environment allows us to sleep at less than 30 decibels. People having a conversation is at 60 decibels. The pitch of a sound is expressed as its frequency, measured in hertz, which is the number of vibration cycles per second. The healthy human ear is sensitive to frequencies ranging from around 20 Hz to 20,000 Hz. The 4 different types of sound that can be experienced within a building are 1. Outside noise, 2. Internal noise, 3. Impact noise on floors, 4. And equipment noise from heating systems, water pipes, etc. These noises can be transmitted through the air and through the building fabric. The way sound behaves and the way the human ear perceives it depends directly on levels of reverberation and absorption within the building. The socio-psychological aspect of acoustic comfort. The effect of sound on well-being also depends on individual psychological responses. Several parameters interact. The familiarity of a sound, its predictability, its controllability, personal sensitivities. For instance, we're always more tolerant of noise from well-liked neighbours than from others, and the acceptance of noise always depends on the type of activity performed. Designing for acoustic comfort. To design acoustically comfortable buildings, it is important to take into account the needs of the occupants, as well as a variety of external and architectural factors. The activities to be performed, the types of noise to be managed, the spectrum of noise to be managed, the construction type and building materials used. However, sound is difficult to predict, Computer simulations are very useful, but cannot replace on-site testing and the experience of an acoustic engineer. The future. Indoor acoustic landscapes are changing, and this will continue in the coming decades. The development of better insulated buildings will also reduce our tolerance to internal noise, particularly as the change in living habits will mean that more and more different activities will have to coexist in the same building. Building materials, construction types and technology are evolving to counteract these growing challenges.